For this next video, I'm going to deal with the first topic, rather in the style of a mystery tour. You do remember this feature I showed you where you can go undo, and I don't think I did show you before, but there's R for redo as well. I want you to try and imagine you're the developer of this code when that feature didn't exist, and your manager or somebody comes along and says, right, we're going to put undo redo in now. And I want you to try and imagine what the implications of that might be in your code. How hard is it to retrospectively put in undo redo to a typical application? And I hope you agree the answer was, well, actually that's really rather difficult. And this is where the command pattern comes in. And I often think the command pattern is one of the less well understood patterns. But let me just show you how we've used it in this source code to make adding something like undo redo really not very difficult at all. So here's our command class. It's a single point through which all the user's mandates to make changes to the current document are routed, so they can be consistent, in other words. And when the command object is instantiated, one of the things that it receives is a new document receiver for undo system. And that's only an interface. If I were to go and look at that in the source code, you'll see it's a trivial interface, which means that whatever you pass in there, the only thing it's got to conform to is the obligation to have this method called on it. Here's a new document. And you'll see there's a method in this class for all the different things that you can do to the model, and there's not so many. And most of them have this at the end, the ones for which it's appropriate. They have a little call to something called notify undo of change. And all that does is it accesses the changed document receiver, and it calls that method that was mandated by the interface. Here's a new document. Now if you think about it, there's two features of the way this code has been architected which makes that so easy to add undo redo. One is that all the substantive changes that the user can make are fed through this class, and therefore it's only this class that needs to know anything about undo redo. The rest of the system doesn't have to know anything about it. And the other thing that is worth noting is that what's passed in is simply a thing that can receive a changed document. So this model, the command class, isn't coupled to the undo redo system. It's only coupled to a thing which can be told about changed documents, which makes it all very much easier to change in the future. Now I said it was going to be a magical mystery tour. Imagine you've just delivered your undo redo, you're very pleased with yourself. So the manager comes back and says, oh, I forgot to mention there's something else I want. That never happens to you, I'm sure. And what I want is a macro system. I want a scripting language bolted onto this so that users can write their own macros. Now if you had this system, you wouldn't tear your hair out in despair at that point. You say, well, that's ever so easy. All I do is produce whatever programming system I like, whatever macro system I like, or maybe I just lift one out of the box that already exists, and I just provide an API into this command class. And it needn't be coupled to anything else, and it's beautifully testable under program control because there's no GUI connection to it either. The next thing I think is interesting to talk about is the display subsystem for this app, because with the best one in the world, it has to be quite complex. It's got an awful lot to do. And so that raises the question, how do you organise the code when there's going to have to be a fair amount of it to do this job? And I'll just give you a bit of a survey of how we've gone about it. It looks quite innocuous there, doesn't it? Display model. But in truth, it's split up into quite a few packages. And in truth, those are subdivided also. Now if you just look at that, for example, I think I showed you earlier that there is a display model, which is the container of all the things that are going to go on the screen. And it kind of figures that the builder is a sub-package which knows how to build one of those display models. But you see how that's even split down further into a sub-package called augmenters. Now this lets us have an augmenter for when you're dragging a symbol. So for example, we have isolated code in there which knows what graphics should be added to the display model in order to support the notion of highlights and dynamic behavior when you're dragging a symbol. And that will add in those special graphics to the display model. Now notice I'm talking in model terms. I didn't say it rendered them, it adds them to the model. So all this thing is doing is building up a display model which is a snapshot of what the diagram should look like at any one time. It's not drawing anything yet, it's just building a model. And the great joy of that is it's completely programmatically testable. And if ever you want to change it, you can make a change, you run your regression tests, and you can be quite sure that it's right. Then, as you want to build your rendering system, you can decide how to render it. It's decoupled. The rendering decision making and the rendering algorithms can be separate, and they can be tested separately. And you don't have to take any interest in how you come about building the model to render. You just know you've got you can test them separately. You know you've got a model to render, and you can you can test the rendering separately. The rendering lives down here, and that's a little subsystem too. It's got the main entry point class, the display model renderer. That's got a method in it which says, right, go render. But that subdivides its responsibility. It has a single item renderer which does one symbol or one link or one waypoint. It has a primitive renderer which just packages up some rendering shapes, rendering fills, and so on. I mentioned in one of the earlier videos a culling policy, so that's there. That has methods in like, should I include ports at the moment? And it'll depend on the zoom level, and so on. Now the point I'm trying to illustrate here is that sometimes inevitably we have to write quite a lot of code to get a job done, and it's worth putting a great deal of thought as to how to organise it so as to provide a navigable set of code for new people to, and you coming back to it in 3 years' time to better find things. The next topic I want to bring up, we're kind of reaching conclusion level topics now. Hopefully in the fragments of code you will have seen here, you'll have seen that most of the classes are pretty small. I mean, let's just look at that one. There's really not very much to it. Now that is actually very important. It's not just nice. And the reason it's important is that any developer can be reasonably expected to read that and get a perfect model of what that's doing in their head. And they can then think about that and that alone. When they go to another class, they can look at that and that alone, and it divides up the conceptual space, and it makes human beings able to cope with much greater levels of complexity if they can divide it up and think about one small piece at a time. There's comments in here, there's naming conventions like using uppercase letters and proper use of enumerated types, and there's a whole bunch of things that you might regard as sort of good professional coding practice. Me and my team at Altran are very, very picky about coding quality, because we all depend on each other to produce decent quality code to make it efficient for us to offer a service to our customers. And we don't leave judgment and communication of what's best practice to chance. We've actually created a portal. You'll see I'm looking at it in a web browser here, Professional Coding Quality. And it has coding guidelines for this. These are generic guidelines for all languages. You know, what makes a good comment? What does defensive program mean? What should you do and what needn't you do? All with examples. What should your position on operator, depending on operator precedence, be? How should you name your method? And this is a wiki, so people can contribute and comment, and people do. And we've got more. We're gradually building it up. And if you feel that this might be of use to you or of interest to you, we're not going to put it in the public domain, but if you'd like to get in touch, and you're a worthy cause, if you like. I don't mean charitable, I mean someone that's going to get a benefit from it and contribute to it. I'll be glad to give you access to it. We want this to become a little community of best practice and knowledge, and I'll be very glad to share it. Another useful technique for preventing judgment of whether code is good from a quality point of view is to try and remove some of the subjectivity from it. And people in academia have come up with some quite decent measures. It was rather better than they were in the old days. In the old days it was how many lines of code there were. And there's a lovely apocryphal story about, I think it was Brian Kernighan in the early days of C and Unix. He managed to reduce the number of lines of code that a piece of software had. And at that time managers thought it was a good idea to pay people according to how many lines of code they wrote. And so he rather tongue-in-cheek went to the managers and said, I've reduced the amount of code that's required to do this job, how much do I owe you? Anyway, on a more serious basis, you can buy you can get for free plugin packages for development environments. Like I've used one called Metrics in Eclipse here, and these are some of the things it can continue automatically from your code. We do have lines of code, but that's not as a measure of excellence. That's as just so you know how much code we're talking about. And in this particular case, the code you've been looking at, there's 6,000 lines in the application and 1,000 lines in the utilities. And these are averages, so that the average number of attributes in the classes, in all the classes, is 2.9, which is quite good. It tells you that if you're trying to get your head around a class and there's only 3-ish attributes, it kind of tells you you're not going to get too overwhelmed with getting that in your head. Making sure there's not too many classes in the package, an average of 3.4, again pretty respectable. Number of lines of source code per method. The smaller this can be, the better, because it means that you can get your brain focused on one particular thing. If you can see the whole job that it does in a few lines of code, it's going to have to be easy to understand. Number of methods per class. How many levels of indentation and nesting on average? This is a rather cunningly developed measure of complexity, and the general advice is that if it ever gets above 10, you really need to think about reorganizing that module. So I'm quite pleased that we've managed to get an average across the whole piece of 1.4. And if ever you come across a method or a function that's got sort of 13 parameters, you think, oh crumbs, this is going to be hard. If you can keep the number of parameters down to 1.46 as an average, you're doing quite well. And these numbers are of similar sort of size to these. So all the code this is a measure of all the code I've shown you and all the bits I haven't shown you which go into part of it. And it just goes to show that even something doing a fairly sophisticated job can have code which is objectively simple and easy to understand, and the commercial benefits of that are absolutely enormous. Now, that brings me to the end of the talk, pretty much, and it rather begs the question, how do I finish? I think the things I want to get across is that I wish I'd had 10 times more time, because I've got so many things I'd like to talk about, but we have to be realistic. Anybody that'd like to be in touch, I'd be glad to speak about it some more. I'm just going to draw your attention to another document that we've created, which you might be interested in. And that's this document. We've called it a white paper, which is perhaps stretching a point because it's quite a big document. And it's a theoretical study of the design of this type of app that we produced before we actually started experimenting. And it's a theoretical look at what a good design for a network editor might be. And we've tried to write it in a way that paints lessons of what good design practices are. Either get in touch with me to get hold of that, or if you go to my LinkedIn page, you can find a link to it there. So of course I have to finish back on this slide. That's how to get in touch, and I do hope I've interested you, and be delighted to speak to you in the future if you're interested in similar things.